Hi, my name is Roddy Conradi, and this is my Week 1 update for the Foveated Vision System project. I meant to do this last Friday, but since it was Memorial Day weekend, I did not have time. I hope to make an update video each week to talk about where I am currently and where I want to go next. This week, I've been working on my Foveated Vision System library. The FVS library contains 3 classes: the Foveated Vision System class, the Capture Device class, and the Vision class. The Foveated Vision System class acts as a master class for the project. It controls the cameras and handles signals. There is a capture device object made for each camera. It reads in the original image feed from the camera. Finally, each camera can have multiple vision objects. This class is responsible for frame-by-frame calculations. The bulk of the project will be done in the vision class. In addition to the fvs.py file, I have a config.py file. This file will be responsible for storing the parameter values of the vision objects. The config.py file allows me to explore my design space in one easy-to-navigate file. For example, one design might be to have 3 vision objects: the main foveal, the parafoveal, and a peripheral vision. Each vision object has 3 values: the ratio, which tells you how much of the original image is contained in the new image; the size, which tells you how many pixels are in the new image, so this image is 100 by 100, and the job that it is responsible for. This image is responsible for printing out the current, the previous, and the log, and the linear polar. Another design might be to have 5 images. We can do this by adding more vision objects to this dictionary. For example, I changed my names here to Vision 1, Vision 2, Vision 3, Vision 4, and Vision 5. Each of these visions is responsible for a separate job. Let's run the first one as an example to see where I am currently on my project. We can run the example.py file to test the code. As you can see here, it's popped up a couple different frames. I have my peripheral gray, my parafoveal current, my main foveal linear, my main foveal log, and my main foveal previous. This corresponds to the different visions and their different jobs. As you can see here, the main foveal current corresponds to this job, the main foveal previous corresponds to the next job, and so on. Why don't we try the next design? In this design, I have 5 visions. Each vision has a new job. The pixel count went up a little bit. I put it to 124. Let's run this code. As you can see, it's popped up a few new frames. You can see an edge image here for Vision 2, which we can see is in the jobs for Vision 2. Vision 5 and 4 don't have any jobs, so there won't be any vision frames corresponding to those visions. Let's run one more example that only has one vision. We'll call this vision example. This vision is responsible for jobs log, polar, and gray. As you can see, there's only 2 frames that's popped up here: the log polar and the gray image. So this is where I am currently on my project. Next, I want to explore the log polar images some more because I've been doing some research and it seems like a lot of past projects exploring foveated vision use log polar imaging. I also want to add some more features to my FVS library, including facial recognition and facial classification. I want to see if I can do this later on using neural networks, but for now I'll just use the OpenCV library facial recognition. I've been using OpenCV a lot for this project since it's easy to navigate and has a lot of pre-built functions. I also want to explore camera gimbals. So I've been looking into servoses and Arduinos to make a camera gimbal. I want to get 2 cameras so that I can calculate distance using triangulation. As you can see here, I'm only using one camera. If I wanted to add more cameras, I can. Each camera is on a separate thread. So if I wanted to add a camera index 0 and camera index 1, I can just add a 1 here. Unfortunately, I only have one camera on this computer, so I'll be keeping it to 0 right now. However, I did test this on my laptop, and it does work. I'm also going to be doing some more research into Foveated vision system projects that other people have done to see where else I might want to go with this project. I plan to use this project for modeling 3D environments. So it calculates distances from walls, recognizes objects, and creates a 3D map. I also want to focus on attention grabbing later, so how to change the attention so that the foveal, or the center of the image, transfers and moves around to explore the room. This is a little summary of where I am now and where I want to go next. Thank you for listening.